Today we will start the lecture on construction management and law. So already in last lectures we have seen various problems related with the critical path method. We have seen various problems related with the how to draw the network diagram. We have seen the problems. Okay? In last lectures we have drawn the network diagrams depending upon the durations, depending upon the activities, which activity is dependent on the previous activities. So depending upon all these activities we have drawn the network diagram in last lectures. Okay? So in today's lectures we will have some more problems on construction management and law. That is we have to draw the network diagrams. So we will see some more problems. Before that we will revise something, that is how to calculate the times. Okay? So there are basically 4 different types of time which is very important in order to calculate or in order to draw the critical path method, in order to find out the critical path method. Already we have discussed in last lectures what is critical path. The critical path is nothing but the longest route with in order to complete a project. What is the duration required, longest duration required in order to complete a project. Okay? So critical path method that is CPM method, that is critical path method, is nowadays it has been used frequently in order to draw network diagrams. So therefore it is very important method in order to draw a network diagrams. So we will discuss in today's lectures the 4 important time concepts. Okay? Already we have discussed this time calculations. So already we have discussed in unit number 2, that is time calculations. I am repeating this 4 times because we have to calculate this times. Okay? We have to calculate the times. So therefore we will revise this. Earliest starting time, that is earliest starting time, it has been denoted by EST. What is earliest starting time? The earliest time at which the activity can start, given that all its precedent activities must be completed first, all the previous activities to be completed first, and we are starting the next activity. Only after completion of the previous activity the next activity will be started. So we have to calculate the earliest starting time only after completion of the previous activities. If the previous activity it has been completed, that means we can calculate the earliest starting time. Okay? So this first is very important. We have to first calculate the earliest starting time. So we will calculate in the network diagrams, we have to calculate this earliest starting time. Okay? The earliest starting time is nothing but the earliest time at which the activity can start, given that all its precedent activities must be completed first. So it is just a denotation. It has been given as capital E. It is denoted as capital E, that is earliest starting time. What is earliest finish time? The earliest finish time is nothing but the earliest start time for the activity plus the time required. Okay? When the time it has been added to the earliest starting time, when earliest starting time it has been added with the time, that is nothing but the earliest finish time. Okay? So what is serial number 2? Serial number 2 is nothing but the earliest finish time. We have to calculate the earliest finish time. So what is the earliest finish time? The earliest start time for the activity plus the time required to complete the activity. So when the time required or when the duration required it has been added to the earliest starting time, so we will get the earliest finish time. Okay? So in order to get the earliest finish time, we have to add duration of that particular activity with the earliest starting time, Okay? So in this way we can find out the earliest finish time. So what is serial number 3? Serial number 3 is again important, that is the latest finish time. What is latest finish time? The latest finish time, or the latest time at which the activity can be completed without delaying. Okay? Without delaying the project. Okay? So without delaying the project we have to complete the particular activity. That completion period or that completion the time required to complete that activity without any delay is nothing but the latest finish time. Okay? The latest time at which the activity can be completed without delaying beyond its targeted completed time, without delaying the targeted time. Okay? So without delaying the targeted time, we have to complete a particular activity within the stipulated time, within the targeted time, within the prescribed time. Okay? So such completion of this activity is nothing but the finish time, latest finish. This is nothing but earliest starting and this is nothing but finish time. Okay? So we have to calculate these two things in network diagrams. So this EST and LFT, earliest starting time and latest finish time, it is very important. These two is very important. Earliest starting time is also important and earliest finish time is also important. Okay, so these two things is very important. We will calculate earliest starting time also and earliest finish time also. So these two things we will find out in this. Okay, so earliest starting time and earliest finish time is very important. We will calculate this. Okay, so in every problem we have to calculate earliest starting time and latest finish time. What is latest finish time? The latest time at which the activity can be completed without delaying beyond its targeted completion time, the project. That is denoted by capital LJ. Again there is fourth time is nothing but the latest start time. What is latest start time? The latest finish time minus the time required. Okay, when it is being subtracted from the time required, the latest finish time minus the time required to complete the activity is nothing but the LST, that is the latest start time. Okay, so in every problem these two times we have to calculate first, and depending upon these two problems, that is we are calculating in every problem in network diagrams, we have to calculate these two first. In first thing we have to calculate these two, that is the earliest starting time and latest finish time. Depending upon this earliest starting time and latest finish time, we will calculate earliest finish time and latest start time. Okay, depending upon EST and LFT, we will calculate further as EFT and LST. Okay, so these four time concerns are very important. These four time concepts are very important. So once again I am repeating that after drawing the network diagrams, we have to first calculate this serial number 1 and serial number 3. Okay, this serial number 1 and serial number 3, that is serial number 1 is EST, earliest starting time, and latest finish time. First we have to calculate, and depending upon these two times we will calculate serial number 2, that is earliest finish time and latest start time. Okay, so this will be more it is easily explained in the problems. Okay, so we will see the problems, how to solve the problems we will see. Okay, so this will be more it will be explained in the problems. Okay, so these four concerns are very, that is EST and LFT, that is earliest start time and latest finish time is very important. Okay, so we'll see the problem, what the problem says. So here we are having a problem. Okay, so here it is in the problems, these things are calculated, these things to be find out what the problem says. Example, we have already discussed in last lecture 3 examples. So here fourth example is nothing but in order to calculate the times required. Okay, so draw the network diagram depending upon this table. Here table will be given, here activities will be given, here durations will be given, and depending upon these activities, depending upon these durations, we have to calculate. What we have to calculate? To draw the network diagram, first we have to draw the network diagrams and find the EST, that is earliest starting time, earliest finish time. LST is latest start time and latest finish time, and total float. Total float is the number of durations by subtracting, we will see total float. Okay, so total float is nothing but the durations, the number of days which has been left over. Okay, so we will see how many days it is left over. Okay, so first we have to draw the network diagram depending upon this table. Then we have to, depending upon after drawing the network diagrams, these four times to be calculated, and depending upon these 4 times we have to find out the total float, and depending upon this total float we will find out, or we will draw the critical path method. We will find out the critical path. Critical path is the longest route we have to find out, the longest path we have to find out. Okay, so first we will draw the network diagrams. Without wasting time, we will draw the network diagrams. So first we will draw the network diagrams. So first activity is nothing but 1 to 2. So starting point is 1, that is event is 1 to 2. 1 is also event, 2 is also event, and connecting to this is nothing but the activity. So we will draw the network diagrams. Okay, yes, so first is 1 to 2. So here we will draw the serial number, that is event 1. 1 is starting point is 1 to 2 and 1 to 3. That means 1 is the starting point. First event is the starting point, and we are starting from 1 to 2 and 1 to 3. That means we have to start from that is event 1 to event 2 we have to draw, and the duration is nothing but 20 days, 20 days or hours, whereas 1 to 3, that is the starting point is also 1, therefore we will draw 1 to 2 and 1 to 3, that is both these activities is having the same starting point as 1. Okay, so we will draw this, we will copy this. Yes, yes. Okay, so this is nothing but the one, so we will give the name to this, so we will give the name to this also. So this is nothing but 1. Okay, yes. 1 to 2, so that means 1 to 2, so 1 to 2 is having a 20 days, so we will write down 20 days also. So first we will give this name as 1 to 2, so this is also 2. Yes, 1, 2, that is having a days as 20 days. So 1 to 2 activity is having a days of 20. It may be for hours, it may be normally it is for days, or normally it is for weeks also. So there is no as such given. So 20, we will write down 20. It may be days or it may be weeks. So we will write down here as 20. 20. Okay. Yes. So this duration is nothing but 20. Okay, what is 1 to 3? 1 to 3 is again having a duration for 25. So we will copy this. We will write down this as 3. Yes. What is the duration for this? So again the duration for this, we will copy this as 25. The duration for this is 25. 25. Yes, it's completed. So 1 to 2 is having a duration for 20 days. 1 to 3 is having a duration for 25 days. Okay. Again, the next activity, it has been started from 2 and it has been ended at 3. Again the next activity, it has been started from 2 and ended at 4. So we will have the activity starting as 2 and ending as 3. Matlab, it will be at the same line, and next activity it is starting from the again 2 to 4. So 2 to 3 we will have this as 2 to 3. Yes, 2 to 3. It is starting from 2 and ending at 3. Yes, 2 to 3. What is the duration for this 2 to 3? The duration for this 2 to 3 is 10 days. So we will copy this. Yes. What is the duration for 2 to 4? Again the duration for 2 to 4 and 3 to 4, that means 4 is having a common point. Okay? So 2 to 4 and 3 to 4, that means end point for this activity is same. So we will draw at center. Okay? We will draw at center. Yes. So 2 to 4 it is having a, yes, 2 to 4 it is having a days in days as 12 days. So we will copy this as 12 days. So this will be 12 days. Yes. We will call this as activity 4. So we will call this as activity 4. Activity 4. 2 to 4 it is having 12 days. Again 3 to 4 it is having 6 days. So again there is a activity for 3 to 4. Okay. So we will start from 3 to 4. So 3 to 4 will have a weeks in 6. So 6 we will have this. Okay. What is next? So 2 to 4 it is having 12 days, 3 to 4 it is having 6 days. Then last activity is nothing but 4 to 5 it is having for 10 days. So we will draw last as a straight line, and it will be as and this we will have this as 5. And what about days? 4 to 5 it is having a days of 10. So 10 it has been repeated, so we will copy this same as 10 here. So in this way we have drawn the network diagrams. Okay. So drawing the network diagram is very important. So first we have drawn the network diagram depending upon the given conditions, depending upon the activities, depending upon the durations. First we have drawn the network diagram. So we will check the network diagram whether this network diagram is there any change in the network diagram or in durations. 1 to 2 is having a duration of 20. Yes, 1 to 2. 1 to 3. So 1 it is having the same starting point. 1 to 3 it is having a duration for 25 days. 2 to 3 it is having a duration for 10 days. Yes. 2 to 4 it is having a duration for 12 days, because it is having same 2 to 3 and 2 to 4 it is having same common point as 2. So 2 to 3, 2 to 4, but durations are different, 10 and 12. What is next? Next is nothing but 3 to 4 it is having a duration for 6 days. Yes. And 4 to 5 it is having finally as the 10 days. Okay. The most important is to draw the network diagram depending upon this table or depending upon the given data. First we have to draw the network diagrams, and after drawing the network diagram, these 4 times to be calculated, and we have to find out the total float. Okay. So these 4 times are very important, and we will find out the further as total floats also. Okay. So for finding out this 4 times, first we will find out the as I have already said, in 4 times serial number 1, and that is serial number 1 in the sense earliest start time and latest finish time. Earliest start time and latest finish time. Earliest start time and latest finish time first we have to calculate, and depending upon this we will calculate the further things. Okay. The earliest start times and latest finish time. So first we will find out the earliest start times and latest finish times. So for that we will first draw the rectangular part for this, because it is to be written here, or I will draw here. Yes, earliest start time. Yes. So these two we will denote. First box we will denote as earliest start time. Next box we will denote as the latest finish time. Earliest start time and latest finish time, or we will write down here also. Okay. In order to there will not be any confusion. So these 2 things we have to calculate. Okay. So I am writing down here what we have to calculate in the first box. The first box we are calculating as earliest start times. Okay. So earliest start time, and next box we will calculate as earliest finish time. So earliest finish time, earliest start time and latest finish time. Okay. So these 2 things we have to calculate. Okay. So these 2 things first we have to calculate, that is the earliest start time and latest finish time. So we are calculating these 2 things, earliest start time and latest finish time, for this activity 1 to 2. For this event 1 to 2, we have to find out earliest start time and latest finish time. For this event 2, we have to find out EST, that is earliest start time, latest finish time. Same way for event 3, we have to calculate EST, LFT. Same way 4 and 5. For all this, we have to calculate this. Okay. So we will copy this for each. So here we have to calculate for this also, for this also, for this also, and finally for this also. So first we have to find out earliest start time and latest finish time for all the events. This circular part is nothing but a node which is called as event. Okay, this arrow part is nothing but the activity. Okay, so 1 to 2 is nothing but from first node to second node. The activity is having a duration for 20 days. Okay, so we have to calculate this. So we will find out the earliest start time. So how to find out the earliest start time? The earliest start time, so we have to see the starting node. For start time, we have to see the earliest start time, we have to see the starting node, and latest finish time, we have to see the finish node, that is the end node. Okay. So first we will calculate from forward directions, we will calculate all the earliest start time. Okay. For all activities, we will calculate the first earliest start time. The earliest start time will be started from the earliest first node 1 to 2. That means the first node is 1. The earliest start time we have to find out for 1 to 2, that is 1. What is earliest start time for 1? So as it is starting node, so there is no as such durations for this. So we will have this as directly as 0 and 0. Okay? We will directly have this as 0 and 0. So 0 and 0. So this we will have as 0 and 0. So the first activity is nothing but, first we are calculating the earliest start time. The earliest start time for this activity is nothing but 0. The starting time for this event is nothing but, is there any event preceding this? There is no as such event preceding this. Therefore, the earliest start time for this is 0. First thing, while calculating the earliest start time, one thing it is to be kept in mind that it is to be calculated in forward directions. Okay? Earliest start time to be calculated in forward directions, and we have to have the first node. We have to see the first node for in order to calculate the earliest start time. Okay? So we are calculating earliest start time. So is there any 1 to 2? So we will see 1. So is there any duration for 1? There is no duration for 1. That is 0. Okay? So that means earliest start time for this first is nothing but 0. Again, LFT will be latest finish time will also be 0. So we will see next way. First starting point will be 0 and 0. There will be starting point, as there is no as such. So starting point will be 0 and 0. Next we will see what is the earliest start time for the event 2, for the activity 1 2. So for this activity we have to add what is the earliest start time. The earliest start time, only after completion of this we will start the second event. So it requires 20 days. So 1 to 2, here it will be it will have the earliest start time as EST as 20 days. So 0 plus 20, 0 plus 20, 0 plus 20 is nothing but 20. That means this 20 will be taken as this. Okay? So we will take this 20. We will have this 20 as here. Okay? What is the earliest start time for again the activity 3? So 0 plus 25. 0, this earliest start time. First we are calculating earliest start time from the starting node. So 0 is the earliest start time. What is this activity? 25. So 25 plus 0, this will be the earliest start time for this event 3. So 25 will be this. So we will have this as 25. So we will copy this 20 and we will edit this as 25. Okay? This as 25. Okay? What is the earliest start time for this activity? So this, it is having two activities. First, from this 2012, this fourth activity, it is having two arrows in forward directions. That means first we can calculate from 1 to 4, we can calculate EST, or we can calculate 1, 3, 4 as EST. So maximum durations to be calculated. What is the maximum value we have to calculate it? While calculating EST, we have to take the maximum value. So earliest start time, we have to take a maximum value for this. So in this route, this 1 to 4, that is nothing but 20 plus 12, that is 32, and this, in this route, that is nothing but the 31. So what is maximum? So 30, 20. Again this route is also there. Okay, now for this route is also there. 1 to 4 is one route, 1 2 3 4 is also one route, and 1 3 4 is also one route. Okay, so out of these three routes, what is the maximum value? So EST, we have to take the maximum value or maximum durations to be calculated. Okay, so we have to take the maximum durations. Okay, so there are three routes which are connecting to this fourth node. This fourth node is connected with three routes. 1 2 4 is the first route, which is having a duration for 32 days. What is second route? Second route is 1 2 3 4. 1 2 3 4 is the next route. What is its duration? 20 plus 10 plus 6, that is 36. First route is having a value of 32. Second route is having a value of 36. And what is the third route? Third route is nothing but 1 3 4. 1 3 4 is having a value of 25 plus 6, that is 31. So what is the maximum value? The maximum value is having this route as zigzag way, 20 plus 10 plus 6, that is 36. That means this value is the maximum value. So how we have calculated earlier start time? The maximum value to be taken. Okay? So there may be number of durations. So out of this number of durations, we have to take the path which is having the maximum durations. We have to select a path which is having a maximum durations. Okay? So we are taking a path as 1, 2, 3 and 4. Why? Because 1 2 is having a duration of 20, 2 to 3 is having a duration of 10, and 3 to 4 is having a duration of 6. That means 10 plus 20 plus 10 plus 6. All these three added, we will have the as 36. So that means we will take maximum as 36. So we will copy this and we will take this as 36. So we will copy this and we will take this as 36. Okay, 36. So up to this, it has been cleared how we are calculating earlier start time. The earlier start time is the value which is maximum, the maximum durations to be calculated. Okay, earlier start time. Okay, earlier start time to be calculated by maximum. Okay, so here there are three routes are there: 1 2 4, 1 2 and 4, 1 2 3 and 4, and 1 3 and 4. Out of this, we have chosen the route as 1 2 3 and 4. Why? Because value we are calculating as maximum as 36. First value, from first route we have get the value as 32. From second route we have calculated as 36. Third route we are getting a value as 31. So out of these three values, the maximum value is 36. So therefore we are taking 36 as the maximum EST, earlier start time. So in order to calculate earlier start time, one thing is to be kept in mind: we have to take a maximum value. Okay, maximum value in the forward directions, maximum value in the forward direction, and where the arrow meets. Here for this fourth node, here we are having these arrows. Okay, so depending upon this, how many arrows are meeting to this. Herein, while calculating 2, only one arrow was calculated. So we have taken this 20. In this 3, again there are 2 arrows. Sorry, 3 is also somewhat changed. We have to change this third value, because again we have to take the maximum value. So again this 3 is having 2 arrows. This 3 is having 2 arrows. So this 25 will be changed, because this 25 is the direct value 1 2 3. But maximum value is 1 2 3. So this 25 will again be changed as 30. So this will be changed as, because we are having a maximum value, we are taking a maximum value. तो we will have this as maximum value. ठीक है, तो we will take this as 30 as 36 because this maximum value. Here this 2 arrows was there because 1 2 3 was first root and 1 2 3 was also another root because these 2 arrows are there. ठीक है, these 2 arrows will be there. ठीक है, again this EST is 36. What is finally the EST for this? So EST for this 5 is nothing but only one arrow is meeting to this, that is only this 36 plus 10. So this is nothing but the final value as 46. So this is nothing but the 46. So this we will take as 46. It's 46. Okay. So in this way we have calculated the earlier start time. So earlier start time is very important. So yes, we are calculating the earlier start time. So earlier start time, while calculating the earlier start time, one thing it is to be kept in mind, it should be the maximum value, maximum durations to be added in order to calculate the earlier start time, and how many arrows are meeting to a particular node, it is to be taken into considerations. Okay? So how many head ends are considered? This is head of this arrow and this is tail. Okay? So head, how many heads are coming to this? So 2 heads are coming or 2 roots are coming. So this is 1 root and this is second root. Okay. So what is the maximum value? Maximum value is 30 plus 6, 36, and this is also 1 root, but we have taken as maximum value as 36. Okay. Again there is only one head is there, that is only 1 root is there to calculate EST. So that is 46. 36 plus 10 is 46. So we are calculating EST in the forward directions. Okay, we have started from first and we have ended at 5. We have started from first node and ended at 5th node. So this thing is very important in order to calculate the earlier start time. How we have calculated our earlier start time? We have started from first node and we have ended to the 5th node. And also in first node EST and LFT, that is the latest finish time and earlier start time, we have started at 0 and 0 because this is the first node. So starting durations will also be as first day will be 0 from then we will have 1 2 3 4 5 say. So first node will have the 0 durations. Okay. So its earlier start time will also be 0 and latest finish time for this first node will be 0. Again for this LFT, these blocks are empty, so we will calculate LFT. So as we have taken for first node EST and LFT as 0 0, same way for the last node we will have this EST, that is earlier start time and latest finish time, as same as 46 and 46. Starting time and end time of this project of network will be same, and we will change the intermediate nodes. Okay, intermediate durations will be changed, but starting point and end points will be fixed. Okay, will be accurate. Okay, starting is 0 0 and end is 46 and 46. That means LFT will also be 46. We will directly calculate, or we will directly take this as 46. Okay. So one thing is it is to be kept in mind, that is the earlier start time and latest finish time for the first activity and the last activity will be same. Okay, first activity will be 0 0 and last activity will be depending upon EST, that is 46 we have calculated from this root. So that means LFT will also be 46. Again now we are calculating the LFT. Okay, that is the latest finish time. So very important is how to calculate the latest finish time is very important. Okay, so how to calculate latest finish time is very important. So we will calculate latest finish time in backward directions. Okay, in backward directions, in reverse directions. We have calculated EST in forward directions, but LFT to be calculated in reverse direction, and we have to see the tail end. While calculating EST we have seen the head end, but while calculating LFT we will see the tail end. Okay, and it will be calculated in the reverse directions, in the backward directions. Okay, LFT to be calculated in the backward directions. 46 is the first. Okay, so we will here subtract. While calculating EST we have added, and while calculating LFT we will subtract. So while calculating LFT we will subtract. Okay, so we will subtract the durations. So what is LFT for this last? That is 46. 46 is nothing but the last LFT. So this 46 minus this 10. So 46 minus 10 is nothing but this 46 minus 10 is nothing but the 46 minus 10. What will be the value? That is 36. So 36 is it is having only one tail end. Fourth node is having only one tail end. That means it is only one having one root. So 46 minus 10 is nothing but 36. So this will be same as 36. Okay. Okay. So up to this we have calculated LFT. Again LFT to be calculated for each nodes in backward directions. Okay, in backward direction. So after that we will calculate for third. Again this 3 is having only one tail end. Okay, it is having two head ends, but it is having only one tail end. Tail end is only one. That means we have to calculate only by one. There is only one way to calculate the LFT. Okay, LFT. So LFT is nothing but for previous is LFT is 36. 36 minus this 6. 36 LFT minus 6 durations will be the LFT for the next durations. So 36 minus 6 is nothing but 30. So this will be again we will copy this as 30 same. Okay. Again, what is the LFT? That is the latest finish for time for 2. So latest finish time for 2, how to calculate? So here there are two tail ends. Okay, one tail end it is from 542, next tail end is from 5432. Okay, because this 2 is having two tail ends. Okay, this 2 is having this second node is having second node serial number 2 node is having two tail ends. So how to calculate LFT? So LFT will be the minimum values. Okay, in EST, that is earlier starting time, we have taken the maximum value. In latest finish time we will take the minimum value. So out of these two directions we will take the minimum values. Okay, so in first direction is 542. So 542 direction is one, and next direction is 5432. That means from 4 to 2 and from 3 to 2. So already we have taken this as 36. So 36 minus 12. So 36 minus 12 is nothing but the how many and this root will also be this. Okay, 30 minus 10, that is nothing but 20. The 30 minus 10 is the 30 minus 10 is nothing but the 20. So this 36 minus 12 is nothing but the 24, and this 30 minus 10. 30 minus 10 is nothing but 20, and 36 minus 12 is nothing but the 24. So what is the minimum value? The minimum value is 20. So we will take as 20. Okay? So while calculating LFT, we have to see the two tail ends. Here these are the two tail ends. Okay? So first is nothing but from 4 to 2 we have to calculate. Next is from 3 to 2. So from 4 it is having LFT as 36. So 36 minus 12 is 24. What is for 3 to 2? It is having LFT as 30. 30 minus 10 is 20. What is the minimum? Out of 24 and 20, minimum is 20. So we will take this as 20. So this as 20. So in this way we have to calculate all the earlier start time and latest finish times. Okay. So in this way we have calculated earlier start times and latest finish time for the above problems. Okay. So we have drawn the network diagrams and we have calculated the earlier start times and latest finish time from this. Okay, it's very, very important. Earlier start time is the maximum value and latest finish time is the minimum value. Whereas earlier start times to be calculated in forward directions, and whereas latest finish time to be calculated in backward directions. Okay, it is to be calculated in backward directions. So these two things to be kept in mind while calculating earlier start times and latest finish time. So earlier start time to be calculated in forward directions, and it will be maximum, whereas latest finish time will be calculated in backward directions and it will be minimum. Okay. So in this way we have calculated for all the nodes we have calculated earlier start times and latest finish time. Again, out of these 5 things we have calculated earlier start time from these given conditions, draw the network diagram and find the EST, EFT, LST and LFT. Out of this and total floats, 5 values, we have calculated only the 2 values in this rectangular form, that is EST, earliest start times and latest finish time, that is serial number 1 and serial number 4 we have calculated. That is first EST we have calculated and LFT we have calculated. Remaining we will calculate it by drawing the tables. So here I will draw the table. I will show the table, and depending upon this further problem will be solved. So here I have drawn Excel sheet in which the same data I have taken care for of same data, and this figure or this network diagram already we have drawn. So again further things to be calculated. So we will see how to fill this table. First we have to draw this table. So this 2 columns, it has been already given in the problem. Depending upon these 2 columns we have drawn this network. It is the same the problem in which depending upon this 2 columns we have drawn this network diagrams, and depending upon this network diagrams we have to fill the remaining things. So we have to first find out EST, that is the earliest start time, earliest finish time, latest start time, latest finish time and total float. These values to be calculated which has been given in the question. So this it has been related with earliest. So I have drawn as I have given this as earliest and earliest start and earliest finish, and its notation as EST, earliest start time, earliest finish time, whereas latest start time, latest finish time and total floats. So these are the various columns to be made in order to calculate the various things related with this network diagrams. So this question it has been asked for near about for 10 marks or for 12 marks. So depending upon the given data, we have to draw the network diagrams, then we have to calculate EST, LFT, that is earliest start time, latest finish time, and depending upon this earliest start time, latest finish time, we have to find out the remaining things. Okay. So first we will feed the data which has been already calculated, which we have already calculated here. I have given the row numbers as 1, 2, 3, column numbers as 1, 2, 3, 4, 5, 6. First activity column we have given the number as 1, duration as 2, and earliest start time, that is EST, we have given the number as 3, EFT we have given the number as 4. Just for simplifications we have given the numbers to the columns. LST we have given the number as 5, LFT we have given the number as 6, and total float we have given the number as 7. So depending upon these 2 columns we have drawn the complete table of these different columns and rows. So while in answers also we have to draw this complete table depending upon the how which things to be calculated. Okay. So in this network diagram which things we have calculated. So we have calculated EST, that is earliest start time and latest finish time. So we will feed the data depending upon this. That means we have calculated this earliest start time and latest finish time. That means these 2 columns we have calculated. Okay. So these 2 columns we have calculated, earliest start times and latest finish time. So first we will feed the data as earliest start times. So first we will find out, or we will feed the data as earliest start time. So earliest start time for 1 to 2 durations, 1 to 2. So starting is 1. So what is EST for 1? EST for 1 to 2, 1 to 2. What is the first number? 1. So starting is earliest is nothing but 1. The earliest start time, while calculating earliest start time, we have to take the first node. Okay, first 1 to 2. So 1 is having a EST as 0. Then in this box part we have taken as 0. So EST for this first as 0. So we will find out, we will take this as 0. 1 to 3. 1 to 3. Simultaneously we have to see the network diagrams in order to feed this data. 1 to 3. What is 1 to 3? So first is nothing but 1. 1 EST is nothing but 0. 1 is EST is nothing but 0. Again 2 to 3. 2 to 3. 2 to 3. What is the first point for this? 2 to 3. 2 is the first point. So for 2 it is nothing but EST is 20. So we will write down as 20. 2 to 4. 2 to 4. 2 to 4. So for EST first is nothing but 2. So 2 EST is nothing but 20. Okay. Again 3 to 4. So for this 3 to 4, first is nothing but, first node is 3. 3 to 4. 3 to 4. This 3 to 4. And first node is 3. What is the value for this? EST 30. 30. 4 to 5. 4 to 5. So for first node is nothing but 4. And what is the node for this? EST value for this? This is nothing but, for 4 to 5, 4 is nothing but 36. So 36. 36. So again in this rectangular part we have calculated EST. How we have feed the EST? The first node we have taken as 1 to 2, so we have taken as 1. 1 to 3 we have taken as 1. 3 to 4 we have taken as 3. 4 to 5 we have taken as 4. Okay. So same way 2 to 4 we have taken as 2. So in this way EST we have taken all these values. Same way LFT we have calculated for every node. So we will find out this LFT. Again first LFT. So these two columns we will calculate later on LFT. So LFT is nothing but, how to calculate LFT? LFT is nothing but depending upon 1 to 2. अब here while calculating LFT, end point we have to take. We have to see the end point 1 to 2. 1 to 2. 2 is nothing but LFT. 2 is nothing but 20. 20. 1 to 3. 1 to 3. 3 LFT is nothing but end point is end node is 3. Okay? LFT is 30. 2 to 3. So 2 to 3, 3 is nothing but again 30, and is nothing but 3 to 4, 3 to 4, sorry 2 to 3, 2 to 3 is 30, okay. What is 2 to 4? 4 is nothing but 36, 4 end point is nothing but 36, 3 to 4, 3 to 4, 3 to 4, 4th is 4 LFT is nothing but, 4 LFT is nothing but again 36. 4 to 5, 5 LFT is nothing but 5 LFT is nothing but 46. So one thing it is to be kept in mind while feeding this EST, earliest start time and latest finish time in the tabular form. While feeding EST we have to take the first node. While feeding LFT we have to take the next node, that is the last node. While feeding LFT we have to take the last node. While feeding EST we have to take the first node. 1 to 2 we have taken as 1. 1 to 3 we have taken as 1. 2 to 3 we have taken as 2, 2 to 4 we have taken as 2, 3 to 4 we have taken as 3, 4 to 5 we have taken as 4. Okay? In this way LFT while calculating 1 to 2 we have taken as 2 for LFT. Okay? 1 to 3 we have taken as 3, 2 to 3 node we have taken as 3, third node, for third node we have taken as 2 to 4 we have taken as fourth node as 36. Okay? Same way 3 to 4 we have taken as third node as 36, and 4 to 5 we have taken as LFT as 46. Once we have feed this EST and LFT in the tabular form, then half problem it has been solved. Okay? Half problem it has been solved. The remaining problem we will calculate, or remaining depending upon this. So already we have seen in the first slide of this starting lecture, first slide of this today's lecture, that is how to calculate EFT, earliest finish time. Earliest finish time is nothing but just the addition of the EST with the durations. Okay? So just the addition of EST with the duration is nothing but the earliest finish time. Already we have seen in the in the definitions. Okay? So we are adding this column 3 to 2. So just I am writing down this as 3 plus 2. This is nothing but column 3 plus 2, column 3 plus 2. This is nothing but not the addition of 3 plus 2 5. It is the addition of columns. This already we have given this column numbers as 1 2 3 4 5 6 7. So it is column number 3. It is added to column number 2. Column number 3 it has been added to column number 2. So column number 3 is nothing but, what is column number 3? So column number 3 is nothing but 0, and it has been added to 2, that is 20. So what is the value? That is 20. Okay? In this way we are calculating the remaining activities. Okay? So same way 0 plus 25, 25, 20 plus 10, 30, 20 plus 12, 32, 30 plus 6, 36, 36 plus 10, 46. So in this way we have calculated this value. Next is again important, how to find out the LST depending upon LFT. Okay? So latest finish time, how to calculate? So here we will subtract. Here while calculating EFT we have added the durations. While calculating the LST we will subtract the duration. Okay? So in this way how to calculate this? That is nothing but 6 minus 2. 6 minus 2. So sixth column, that is the LFT column minus duration column. So minus duration column. So this we will have this minus durations. Minus duration. See? Minus durations. So this minus duration, that means 20 minus duration, that is 20 minus 20 is 0. 30 minus 25 is 5. 30 minus 10 is 20. 36 minus 12 is 24. 36 minus 6 is 30. 46 minus 10 is 36. So this is nothing but the subtraction of columns, sixth column minus second column. While calculating LST, we have to subtract the durations. While calculating EFT, we have to add the durations. So these two columns are very important. Okay? So we have calculated this column. Okay? Next is again important, how to calculate total floats. So total float is is nothing but start or end. Okay? Finish. Start minus करो या फिर end finish minus. Okay? So we will have start minus or finish minus, that is one and the same. That means 5 minus 3 or 5 minus 3 column number 5 minus 3 or 5 minus 3 or 6 minus 4. It is one and the same. Both the values will be same. Okay? 6 minus 4. 5 minus 3 or 6 minus 4 is one and the same. Okay? So it will be one and the same. So how to calculate total float? Total float will be depending upon this 5 minus 3, starting latest start time minus earliest start time, or latest finish time minus earliest finish time. Okay? Start minus करो या फिर finish minus करो, it is one and the same. So in order to calculate the total floats, we have to subtract this start or finish. Okay? So here we have calculated this as start. So we will have this as 5 minus 3. 5 is here, minus 3, 0. Okay? In this way. So these are the values. 5 minus 3 will be also these values, and 6 minus 4, it is one and the same. Okay? So these values are 0, 5, 0, 4, 0, 0. So these are the values. This total float values for this 1 to 3 activity is 5, and total float for 2 to 4 activity is 4. That means these are the extra days which are remaining, but this 0 indicates the critical path. This is nothing but the critical path. Okay? This 0 indicates the critical path. So this 0 is nothing but the critical path. The 0 value indicates the critical path. Okay? So in this way we have to calculate the critical path, and finally we will write down this as critical path here also. So what is the critical path? Where the values are 0. Okay? Where the values are 0. What the values are 0? So this is critical path is nothing but path is what is the where the values are 0. So critical path is 1. What is critical path? The critical path is 1 to 2. 1 to 2 is the critical path. Here 1 to 2 is the critical path, and 2 to 3. That means 2 to 3. 1 to 2, 2 to 3. Then 3 to 4. 3 to 4. 3 to 4, and finally 3 to 4, and finally 4 to 5. These are the critical path. So critical path is nothing but this root is nothing but the critical path. Okay? So the critical path values are very important. How to calculate the critical path? So, in this way we have calculated the critical path. Okay? So here we have to draw a double line for this also, critical path. So 1 to 2 is the critical path, 2 to 3 is the critical path, 3 to 4 is the critical path, and 4 to 5 is the critical path. Also how to find out the critical path? So where the EST and LFT is same, that means that path is nothing but the critical path. Also it is having the maximum value. Okay? So here 46, 36, 36, 36, 20, 20, 30, 30, 0, 0. That means this path is the critical path, but it has been correlated with the values where it has been calculated as 0. So 0 is 1 to 2, 0 is 2 to 3, 0 is 3 to 4, and 0 is 4 to 5. That means this path is nothing but the critical path, and its duration is 46. What is the duration for this? Duration is 46, and its duration is 46. The maximum duration for this is 46. CPM path is 1, 2, 3, 4, 5, and its duration is 46. It may be for weeks or it may be days. So in this way we have solved the problem related with the network diagrams. We have drawn the network diagrams, and depending upon the network diagrams we have calculated EST, LFT, and depending upon EST, LFT we have calculated, or we have drawn the table in Excel sheet, and depending upon this we have calculated the remaining time as EFT. We have calculated the remaining time as EFT and the remaining time as LST. So in this way, as this was a problem related with the how to calculate the different times, so it is very important. So next lectures again we will draw the network diagrams and we will find out the different times related with this. Okay, so if there are any queries related with this, so please ask the queries related with this, or how to draw the network diagrams, or the various calculations related with this. So it is very important first to draw the network diagrams and to calculate the various time things. Okay, so here we will end the today's lectures. Okay, if anyone having problem, so they can ask the problems related with this.